Introduction. In 2022, NASA's Double Asteroid Redirection Test, DART, mission made history by successfully altering the orbit of Dimorphos, a moonlet orbiting the asteroid Didymos. This demonstrated a potential planetary defense strategy against hazardous asteroids. However, recent studies revealed that the collision also ejected debris into space, with some fragments potentially reaching Earth and Mars within the next decade. This has sparked new scientific interest in understanding the behavior of asteroid ejecta and the potential for human-made meteor showers. In this video, we will explore the aftermath of the DART mission, the science behind the debris journey, and why this discovery is so important for the future of planetary defense in space. The aftermath of the DART mission. The DART mission's primary goal was straightforward: to alter the orbit of an asteroid as a means of protecting Earth from future collisions. On September 26, 2022, DART collided with Dimorphos, successfully shortening the moonlet's orbital period around Didymos by 32 minutes, far exceeding the mission's target of 73 seconds. This marked the first time in human history that we intentionally altered the motion of a celestial body, a groundbreaking achievement that validated the kinetic impact technique for planetary defense. However, this success came with a surprising consequence. The collision dislodged a significant amount of debris from Dimorphos, including boulders measuring up to 22 feet in diameter. These 37 boulders flung into space now have the potential to cross Mars' orbit within 6,000 years or possibly even sooner, given the unpredictable nature of space. What makes this particularly fascinating is the sheer scale of the debris. Initially, scientists did not anticipate that so many large boulders would be ejected, but the aftermath of the impact proved otherwise. This debris has caught the attention of scientists around the world as it presents an opportunity to study how asteroid ejecta behaves over time. In the case of DART, researchers used data from the Italian CubeSat LICIA cube to simulate the debris's future trajectories. According to Dr. Elo Pawaseno, who led the recent study, the simulations revealed that particles from the DART impact could reach Earth in as little as 7 years, depending on their size and speed. The slower-moving particles could take up to 13 years to reach Mars, while larger, more robust fragments may remain in space for much longer before making contact with a celestial body. The science behind these projections is based on advanced simulations conducted with supercomputers at NASA's Navigation and Ancillary Information Facility. By inputting the initial conditions of the ejecta, such as their velocities ranging from a few m/s to 500 meters per second, researchers were able to predict where these particles might end up. This kind of modeling is important not only for understanding the DART mission's aftermath, but also for providing a framework for future planetary defense strategies. Monitoring the trajectory of debris from asteroid impacts allows scientists to anticipate potential meteor showers, including a human-made meteor shower dubbed the DART shower. The journey of the ejecta. What happens to the debris after an asteroid collision like the one initiated by DART? Using the data gathered from this mission, researchers have identified two possible outcomes for the debris. It could either burn up in the atmospheres of Mars or Earth, or it could create craters if the particles are dense enough to survive atmospheric entry. The smaller, faster particles ejected at velocities exceeding 1.5 kilometers per second are predicted to disintegrate in Earth's atmosphere within 7 to 30 years, depending on their size. However, the slower-moving fragments are expected to take longer, possibly up to 13 years, to reach Mars. Despite the debris's potential for destruction, the likelihood of it causing any real damage is slim. Instead, it could result in spectacular meteor showers both on Earth and Mars, providing scientists with a rare opportunity to study meteors originating from human activities. The lessons learned from the DART mission will inform future efforts to predict and mitigate the effects of asteroid impacts, especially concerning the secondary hazards posed by debris. According to Stephanie Aswani, a space engineering expert, monitoring the movement of ejecta is essential for ensuring that future asteroid deflection missions do not inadvertently create new hazards. Hera missions follow-up and meteor showers on Mars. The next major chapter in the DART mission story will unfold with the Hera mission, an ambitious follow-up led by the European Space Agency, ESA, scheduled to arrive at the Didymos system in 2026. Hera will provide an unprecedented close-up examination of the impact site left by DART. This mission will be the first to thoroughly investigate the physical aftermath of a planetary defense test. Hera's primary goal is to assess the long-term effects of the kinetic impact method on Dimorphos' orbit. It will gather critical data needed to measure the full impact of this event. Among its objectives is the task of measuring the mass of Didymos to determine whether DART's collision redistributed any significant mass or caused internal changes to the asteroid. Hera will also examine the impact crater left by DART, providing key insights into how asteroids respond to kinetic collisions. Another key aspect of Hera's mission is its study of Dimorphos' internal composition. Understanding the internal makeup of asteroids is vital for predicting how they might behave during deflection attempts. This knowledge could influence future missions, helping scientists design more effective methods for altering asteroid trajectories, whether by kinetic impact or other advanced techniques. Hera's findings will be pivotal in enhancing the safety and accuracy of future planetary defense strategies. As Hera studies the aftermath of DART's impact on Dimorphos, there is also the exciting possibility of meteor showers on Mars. Debris from the DART impact could eventually reach Mars, where it may burn up in the atmosphere, creating visible meteors for future Mars-bound missions to observe. This would mark the first time that human intervention on an asteroid resulted in meteors being seen on another planet. A thrilling prospect for both scientists and explorers. These meteors would not only be a spectacle but also a valuable source of data. Observing meteors from Didymos on Mars could provide unique insights into the Martian atmosphere and how it interacts with space debris. This offers a rare opportunity to study meteor activity on another planet and deepens our understanding of both Mars and the broader solar system. As human exploration of Mars advances, these studies could help prepare future astronauts for the challenges of living and working on the red planet. The exploration of asteroids extends beyond mere collision avoidance. It plays a crucial role in understanding the formation and evolution of our solar system. These celestial bodies serve as time capsules, preserving the conditions of the early solar system. By studying their composition, scientists can glean insights into the materials that formed the planets, including Earth. In recent years, space agencies have intensified their efforts to develop technologies for asteroid mining. The potential resources found in asteroids, such as water and rare metals, could support long-term human presence in space and aid future missions to Mars and beyond. The extraction of these materials could also reduce the reliance on Earth's resources, making space exploration more sustainable. Additionally, the implications of asteroid research extend to the broader context of climate change and global security. Understanding the dynamics of near-Earth objects, NEOs, can help us formulate strategies for mitigating risks, not only from potential impacts, but also from the various ways that space weather can affect our planet. This multidisciplinary approach to asteroid science encourages collaboration among planetary scientists, engineers, and policymakers, paving the way for innovative solutions to challenges we face both on Earth and in our exploration of the cosmos. Thank you for watching. We hope you enjoyed exploring the fascinating aftermath of NASA's DART mission and the exciting future prospects from ESA's Hera mission to the potential of witnessing human-made meteor showers on Mars. Don't forget to like, subscribe, and hit the notification bell so you never miss an update on the latest developments in space exploration. Thanks again for watching, and we'll see you next time.